Hello! This video has to do with linear functions. A linear function is exactly what it sounds like. It's a function that encodes a line. Let's create some arbitrary situation here. We have our Cartesian coordinate system. We have some line here. And we have some x1 here, since this is the x-axis. Here's the y-axis. We have some x1, x2, and the corresponding f of x1, which we'll call our y1, and its corresponding f of x2, which we'll call our y2. Okay? We will analyze the properties of this line. The first definition in order to analyze the properties of lines is that we have to define the concept of slope. Slope, denoted by the letter M, is sometimes called rise over run. Many times people have described slope to you as the ratio of the rise of the line divided by the run of the line. Well, that's one way to define it, but in terms of rigorous mathematical definition, M is really the difference between your f of x2 minus your f of x1 divided by your x2 minus x1. Notice that this f of x2 we also call y2. So this reduces to y2 minus y1 divided by x2 minus x1. Really it's saying, what's this length divided by what's this length? That's really what the slope is. It's the rise, the change in y, divided by the change in x. It's also sometimes called change in y over change in x. And in mathematics, change is sometimes called delta. So another way we call it is delta y over delta x, or delta, that triangle-looking shape is what we call delta. That is there to signify a change or a difference. So now that we've defined slope, I'm going to define an equation for slope. And an equation involving slope is the line equation, or L of x for a line is equal to mx plus b. And I call it L of x, but a lot of times it's called y. Y is equal to mx plus b. Okay? Y is also a function of x. Where this is the slope, okay, and this b is called the y-intercept. Okay, so the y-intercept, exactly what it sounds like. It's where the y-axis is being intercepted by the line. In football, when you catch an interception, poof, that's where you touch the ball on the opposition team. But in mathematics, interception is where it's touching the y-axis. Okay? Now, let's come up with some examples for lines. Okay? Let's take the line y is equal to 3/2 x plus 2. Clearly, this is going to be a line in which it touches the y at 2. There's a 2, there's a 1. Now, this slope, 3 over 2, tells us that it will go up by 3 units and to the right by 3 units because it's positive. So that means I'll go 1, 2, 3, all the way to 3, 4, 5, and 1, 2. That means the line will go up 3, over 2, I put a dot. Up 3, 1, 2, 3, over 2, 1, 2, I put a dot. I connect these dots, and we'll see that it's going to touch the x-axis here. This is called the x-intercept. The way we discover what the x-intercept is we notice that the function y of x is equal to 0 at that point, right? So we set the whole thing equal to 0 and solve for x. So 0 is equal to 3/2 x plus 2. I subtract the 2, I get negative 2 is equal to 3/2 x. Multiply by both sides by 2/3, so I get negative 4/3 is equal to where x is at. So this is located right here at negative 4/3. Okay. Now, this y equals mx plus b, y is equal to mx plus b. This is called slope-intercept form. It is called so because the slope here is highlighted by the m, and the intercept here is highlighted by the b, where b is the y-intercept. Let's do one more example, and then in the next video we'll be talking about another form of lines. One more example here. Let's do the line y is equal to negative 2x plus 3. Okay? Now, what kind of line? Well, it has slope negative 2, y-intercept 3. Another way to discover what the line looks like here, it intercepts at 1, 2, 3, 1, 2, 3. This is where the line will touch the y. It goes down instead of up because of the negative sign, so it goes down by 2 units, 1, 2, over by 1, 1, 2, over by 1, put a dot, 1, 2, over by 1, I put a dot, 1, 2, over by 1, I put a dot, and I connect these dots right here. So this is our line now. Where is it crossing this x-axis right here? Okay, that's the x-intercept. The function assumes the value is 0 here. So all we got to do is solve for x. So I add 2x to get this, and I get x is equal to 3/2. So this right here is at 3/2 or 1.5. Notice that this line is going down. It doesn't have rise over run. It has fall over run. Okay? Rise over run is only true whenever you have a positive m. If you have a negative m, it's more like fall over run. Okay? These are two examples of line equations, and these are two ways to apply y equals mx plus b, which is slope-intercept form.